Dear colleagues, let me introduce our scientific work on the topic the confocal microscopy for assessment of transdermal transport of the photosensitizer chlorin E6 after non-ablative photothermolysis. Recently, the interest in percutaneous drug delivery methods has increased, and every day there is more and more information about the development of new transdermal delivery systems. Actually, the development of new ways to deliver drug molecules through the skin not only improves the characteristics of the drug in terms of efficacy and safety, but also there is contributes to the patient's adherence to treatment. Traditional methods of drug delivery, oral or intravenous, have negative consequences, which complicates treatment and causes the patient to be averse to treatment problems with the assimilation of certain drugs. In this regard, transdermal therapeutic systems are aimed at transferring pharmacological agents through the protective layer of the skin. But the difficulty of creating a vehicle is that many conditions must be met for each drug, since it is necessary to overcome the specific obstacles associated with conventional delivery methods. But despite all the advantages, when used, most drugs are not able to penetrate into deep layers of the skin due to the protective surface layer of the skin, stratum corneum. There are many mechanical, chemical, and physical methods that promote the passage of drugs through the skin, but in most cases, these methods are ineffective and unsafe. Thermal ablation is a method that creates conditions for the transport of medicinal agents through the skin. The local thermal exposure damages the surface layer of the skin exclusively at the site of exposure without damaging the deep structures, which improves the passage of lipo and hydrophilic agents into all layers of the skin. The laser ablation occurs due to the absorption of light energy by tissue cells. The water in the cells evaporates, creating microchannels in the skin. Analyzing the current work on transdermal transport of drugs, we can conclude that the fractional laser photothermolysis is a promising method of exposure for transdermal transport of medicinal agents. As a result of fractional laser photothermolysis, numerous minor skin microtraumas occur, while about 95% of the skin remain intact. In contrast to conventional laser technologies, which focus on continuous exposure across the entire surface of the skin, FLP has a fragmentary effect, causing small areas of thermal damage, called microthermal zones. The healthy tissue surrounding the MTZ ensures rapid recovery of the epidermis due to the migration of viable cells to the lesion sites. The transdermal delivery of the drug through the microthermal zones created by photothermolysis allows to prevent the drug from being metabolized in the gastrointestinal tract and liver, as it happens when the drug is taken orally or administered systemically. These methods improve the pharmacological effect and at the same time reduce the amount of pharmacological agents. Fully, the above applies to photosensitizers. Photosensitizers are a group of drugs used for photodynamic therapy. These are substances capable of absorbing light of a certain wavelength and converting its energy. Activation of PS by light energy leads to triggering of photochemical reactions and the appearance of the fluorescence effect, which can be detected with the help of special devices. One of more important area of investigation is the intradermal, transdermal delivery and cutaneous penetration of different photosensitizers, including after topical application. The laser scanning confocal microscopy is the most suitable method for diagnosing the effect of fluorescence of the drug in all layers on the skin. The purpose of our research is to study the features of transdermal transport of the medicinal photosensitizer chlorin E6 in the form drug of the radiogel after non-ablative photothermolysis using confocal microscopy and calculating the transdermal transport coefficient based on the fluorescence intensity of the photosensitizer molecules. The study included male mice divided into 3 equal groups. The first group of photothermolysis and the application of radiogal photosensitizer, the second group of radiogal application, and the third control group. After euthanasia, a scan flap was excited from the abdominal wall of all animals, and cross sections were prepared for laser confocal microscopy. Confocal laser scanning microscopy technique is fluorescence-based image and offers greater resolution due to its point illumination and the detection properties. To analyze radical fluorescence, microscopy was performed at the optimal wavelength for the study. Fluorescence excitation at 458 nanometers and fluorescence registration at 675 nanometers. Results. In the control group, without exposure to photothermolysis and application of photosensitizers, the presence of background radiation and spontaneous fluorescence of the skin was noted. Confocal microscopy of skin, the application photosensitization alone, active fluorescence fluorescence radical is observed throughout the entire epidermal layer. Microscopy of the skin treated with photothermolysis with application of radical demonstrates the fluorescence of the drug in all layers of the skin and its structures, including hair follicles and sebaceous glands. Presenting the transdermal transport coefficient of the drug as a ratio of the fluorescence intensity in the reticular layer to the fluorescence intensity on the epidermis multiplied by 100, we obtained objective data from which it follows that after a standard cutaneous application of radical, the transport coefficient is 3.68 cu, while the application of the drug after FLP provides a 27-fold increase in the transport coefficient, which is 103.7 cu. In conclusion, we can say non-ablative laser photothermolysis significantly enhances the intradermal penetration of chlorin E6 photosensitizer. The use of confocal microscopy allows us to estimate the depth of chlorin E6 penetration into the skin layers, as well as to quantify the increase in the intradermal distribution of the drug by calculating the transdermal transport coefficient of the drug. During the study, we didn't find any references in the literature about confocal microscopy of cryo material with chlorin E6, so it can be assumed that such a study is being carried out for the first time. Distribution mechanisms and localization of chlorin E6 in the skin structures are of interest, which requires further research in this direction. We express our gratitude to colleagues for their help in the study, and thanks for your attention.